morning. Chapter 10. This is a big chapter, and I mean that in almost every way. It is, the chapter in the book is long, and the keynote is long. It's far and away the biggest keynote that we've had so far. If you looked at that, and the topic is also big in terms of it's a big idea. I remember when I got to this topic when learning object-oriented programming, it didn't make a ton of sense initially, just because everything I had learned, all the languages I had learned were, from machine code on up, were all what you'd call procedural or functional languages, in which you approach the problem by breaking it into steps, and then you code those steps and figure out what the sequence of steps is, and then if the language supports functions or procedures or methods or whatever, then you start thinking about how to modularize or break the complexity up into somewhat simpler, more discrete chunks that can be tackled separately, and pretty much all the languages I had learned work that way. And to a large extent, if you look back on all the work we've done this semester, it's pretty much the same thing. We've been using an object-oriented language, and we have absolutely used built-in classes to create objects that we use, but these were all UI elements. We've used panels and buttons and sliders and text fields and polygons. I don't know if there's anything I'm forgetting in my list, but obviously we've used JFrames to create our windows. So we've used a lot of Java built-in classes. But in terms of our own work, in terms of how we approach the problem, how we think about programming, it's largely been kind of a top-down procedural approach. And to a large extent, of course, our thinking is driven by our knowledge and skill in terms of programming. It's hard to think of stuff in a more complex way unless you know what that more complex way is. So that is the topic today, is how do we take advantage of the object-oriented nature of Java? So it's a shift in thinking. It really is. And I think I've said this before, but ultimately programming is far more about thinking than anything else. Everybody tends to think that it's about syntax, about the language and getting the proper syntax and order, getting the individual requirements of the syntax right. Every semicolon and curly brace and capital letter and lowercase letter, right and in place. And in terms of designing apps, the tendency is to think about, well, the UI. What is it? How do I get the program to look like I want it to look? And so I have the screenshot here of this mock UI for a pirate pizzeria from chapter 3. And certainly you could look at it and say, well, there's lots of objects in there. There's buttons, there's checkboxes, there's a text field, there's a table, there's labels, you can see 2 J-scroll panes in action, there's a tabbed pane, a toolbar, there's absolutely all of these classes that we're using, but these are all built in. The shift today is, how do we make our own classes? Well, initially, syntactically, just what is the mechanics of creating your own class? But then the bigger picture is, why would we do that? What's the payoff? What's the advantage to doing this? So we're trying to tackle both in this chapter, which is, again, why it's a big chapter from multiple standpoints. All right, a shift in thinking. So ideally, in some ways, as an object-oriented programmer, you're going to start to think about your programs as a composition of objects, some of which are built in to Java, some of which you make. Some are placed in the UI, others are not visible in the UI. And we think about those objects as dynamic. They're not just things that we create and we put somewhere and we're done with, but these objects that we create will have behaviors. They'll have appearances and behaviors on screen. They may interact with other objects, and it's that communication and that interaction to a large extent which will create the functionality that we're looking for. I do want to emphasize, everything we've learned so far is still important. You have nothing that we've learned in terms of how to sequence statements, what the flow of execution is, how we control the flow with logic and with loops and with method calls, all of that is still important. Obviously, a tremendous amount of awesome programming has been done using older languages, and even thinking about apps with a windowed UI. Although we've coded that using built-in classes by creating objects, button objects, and so on. Obviously people coded graphical interfaces long before there was object-oriented programming, so I don't want you also to conflate the idea that creating apps with a GUI with somehow that requires object orientation. It doesn't. We are using it, but that's because that's how Java has implemented these features. Anyway, I should have mentioned that earlier. The other cool thing about designing your own classes is that they will frequently mirror real-world entities in the problem space. So we'll create things like a customer class to represent our fictional pirate customers, and these pirate customers will have attributes that make sense to you because you know what a customer is. It'll be things like name and address and credit card number and loyalty program number or point balance or whatever it is we're implementing. It'll mirror actual pirate customers who walk into our, I should say fictional pirate customers that walk into our pirate pizzeria. So moving to this object-oriented programming and way of thinking, it's also another form of modularization. We'll be able to break our program up into discrete elements in the form of classes like customers and products and inventory and suppliers and orders and so on and so forth, depending on whatever we're programming. It's another way, in addition to using methods, that we break up the complexity of the program. But these also take it a step farther in that they're organizing the modularization. They're not just a tool for breaking it up into smaller chunks. Object orientation is also a way to organize those smaller chunks and also hopefully to let them correspond naturally to elements that are in the real-world system that we're programming an app to support. All right, a definition. An object is a collection of data, which we also call attributes. Eclipse calls them, in some dialogues, fields. Some textbooks will call them properties. These are also instance variables, whatever you want to call them. They're the attributes of objects of this class type. And then methods or operations, UML calls them operations again. These are combined in what's called a self-contained bundle. So each class is responsible for generating objects which fully encapsulate the complexity of objects of that type. So pirate customer objects will be responsible for representing the complexity of our customers, storing relevant data, and providing methods that give us access to functions that make sense to work with our pirate customers, like billing them or changing their loyalty club balance or whatever the case may be for the app that we're coding. The idea would be that, for instance, our pirate customer class will create pirate customer objects that are self-sufficient in terms of representing everything that they need to represent to support our app and to faithfully mirror pirate customers themselves. And it's a big idea, this switch from sort of procedural functional programming to object-oriented programming. There's some new syntax to master, but it's what you'll see shortly is it's not all that new. You've been doing it. And also this big picture idea, this shift that we want to try to start mastering. It is in some ways akin to the shift from a flat file database of some sort to a fully relational data model. And in fact, I think you're going to see some similarities between relational database design and thinking about and organizing these classes. If that didn't occur to you already, there is a lot of similarity between coming up with a database table and the fields that are in it and designing a Java class with the attributes and the methods that go in it. So anyway, as an analogy, keep that in the back of your mind. And if you were here last time or you watched the video for last time, we actually created two classes. Class A and Class B. We typed them in. If you were following along, you typed them in. And they were really, really small. Class A, I think, just had one attribute, an integer variable called val. That was it. And that was a valid class that met the needs of what we were trying to learn, which was what the difference between public and private is. So we have done this, and we've done it recently. In addition to, obviously, we've used the built-in classes fairly extensively. And of course, every one of our apps is a class. When Java runs our app, actually what it's doing is it's instantiating an object, an application object based on our class that we've written. So anyway, we've done a lot of this. Here's step one maybe in the shift. If we think of that mock UI, but maybe just think about, what a pizza restaurant is. Obviously I picked that example because we all, obviously we haven't been to an actual restaurant maybe in months, but we look forward again to the day where we will go to our pizza restaurant. Not this horrible pirate pizzeria, but an actual quality establishment. And pretend you've walked into your favorite pizza restaurant. Then you look around, you see pizzas, you see customers, you see checks being delivered to the table, you see beverages, you see desserts, you see seating groups, you see all sorts of stuff that may need to be represented in an app that we're writing to support this business. These are all things that do not exist in Java. Java comes with thousands and thousands of built-in classes, but it doesn't come with most any basic classes that we would need to code, a business application. It is up to us to think about, what is a customer to us? What is important to manage about customers to us, our pirate customers? And same thing with pizzas and everything else. So these real-world entities that we identify as important components of an app that we're writing, we will want to create classes that mirror them, that represent them, that allow us to create objects of that class type, that is pizza objects and customer objects, order objects, beverage objects, and so on. These objects will be created and used in our app. Some of them will have on-screen or visual representations. Others will not. They will be entirely behind the scenes without a specific on-screen element. All right. So instead of initially thinking necessarily about the UI and where I want the buttons, you start thinking about your app more deeply and the business scenario more deeply. Kind of like, again, if you were thinking about designing a database to support this pirate pizzeria restaurant. All right, so where do objects come from? I think you already know the answer to this. Objects come from classes. Classes are the definition. Classes are we described it as the blueprint for objects of that type. So if we want, a pirate customer object, we have to code a pirate customer class. Object is we define the class that describes all objects of a given type, and then we instantiate individual objects from that class definition. To a large extent, when we're writing all of our code, we're coding classes. And then when the program starts to run, we instantiate objects of that type and we do stuff with those objects typically to get the behavior, the appearance, and the functionality that we want in our app. So objects are instantiated from classes. An object is an instance of a class, is another way to say that. Instance is a computer science word, and it should remind you of the syntax. It's instantiation. When we create objects of a given class type, we say object X equals new, whatever, JButton or customer or whatever the case may be. So that's instantiation. And for that reason, also objects are also called instances. And there are textbooks, I've had textbooks which confusingly kind of switch between calling something an object and then calling something an instance, one sentence after another, or even in the same sentence. And it's confusing, I know, especially to beginners, because it makes you think, wait a minute, am I looking at an object or an instance? How's an instance different from an object? You can create two things from classes. You can create instances and objects. No, instances are objects. It's a different term for the same thing. All right, the basic structure of a class. So the thing here is, you already know what the basic structure is because we've been coding classes since the beginning of the semester. Every app that we write has been a class. So when we say public class name extends JFrame, and we have the main method, and we have the constructor method, and we have potentially other methods. All of the syntax that you've learned so far is still the syntax. That is the syntax for creating classes. We've been doing it. So we need, in general, just a few things. One is a class signature with the name of the class. The name of the class is a valid Java identifier of some sort. Then a declaration of attributes, which is typically kind of our list of instance variables. Again, those are defined inside of the class, but outside of any method. I frequently will say that's what we do at the top of our code, just because that's useful to remind you where that should go. But again, the instance variables don't have to be at the top of the code. They just have to be outside of any method. They also don't need to be together. Java doesn't have any sort of structural requirements in that regard, so you can declare some instance variables, say at the top of your code, some at the bottom, some in the middle. Second requirement, or part of the structure, is the attributes, the instance variables, and then the methods that define the available operations. This could be constructor method. This could be what we'll call the getter and the setter methods, which we've talked about a little bit. And then other operations specific to objects of that class type. Things like, for instance, with our pirate customers, we'll have a, maybe get point club balance or get loyalty club balance, or, get membership status, or whatever makes sense given objects of our class type. We may have methods that need to be written to provide us with that behavior, that functionality. One thing to note is at the bottom. If you haven't read that already, I'd just say that unless a class is a Java app, you do not need a main method. So again, the main method is the method that makes a Java class executable. If you define a class as an app that executes, the runtime environment will look for that main method to execute. If it doesn't find it, it will not run. I do see people coding things like, for instance, they'll code their, a class representing pizza objects, and they'll throw in a main method not really knowing what to put in it just because they think, well, it needs a main method, and it doesn't. So do remember that in most of our apps, we'll have just one and only one main method. We'll only have one class that is executable. All the other classes that we create and code, and there may be a handful or a bucket full or more, will not be executable and will not have a main method. If there are multiple main methods, that will confuse Java. These classes that we're talking about today will typically not contain main methods because they're not meant to be executable. You don't run a pizza. You don't run a customer. You run an app, and the main method is what defines how to start the app up. So visually, these are organized typically something like this, so that there's a class name at the top, and an open curly brace and a closed curly brace, which define the body of the class. Everything in between that top curly brace and the bottom curly brace are parts of, member elements of the class. We typically have our list of attributes. These are instance variables, and I normally put those at the top of the code right there and organize them together, but that's just a style convention. What's important is you can see that they're not inside of a method, but they're inside of the class. There's a constructor method. Constructor methods are optional. I think we've said that several times. If you have one, it will be named the same as the class, and code will go in it that helps set up objects of that class type. And then other methods, including getters and setters and other utility methods that we need, are typically placed underneath that. All right, again, just as a reminder, we did create those classes A and B Thursday, and they were super short and easy. Here's a variation on a very simple class that just has a list of attributes. So I've spent a minute thinking about what a customer is. Very similar to how you would think about what a customer table would look like in the database class. And I've come up with these attributes: name and address and city and country and phone number and credit card number. And it's a short list that fits on screen. Obviously, there's potentially dozens of more attributes. Just like in databases, we have to think about what is the data type. Java obviously requires everything has a data type. Hopefully you're getting used to that, maybe starting to appreciate it a little bit even. I don't know. You can see I've got a variety of string attributes, an integer zip code, and a long credit card number. All those are our variable declarations and initializations. It's an initialization because I'm assigning an initial value to it, even though what I'm assigning is empty. I'm saying string name equals empty quotes, semicolon. That still counts. That's a full and complete variable declaration and initialization. Name is now ready to use in any way that I want to. And so are the other attributes. I haven't declared them as public or private. That means that they're default or package access. I don't have any methods. I don't have a constructor. I don't have any getters and setters. I just have this list of attributes. It may seem like that's not enough, that you need something more than that for this to work, but you really don't. A class could be as simple as a single variable declaration. They do not have to be huge and involved, although they frequently end up being fairly large and somewhat involved. So you might wonder if there's no constructor, then how do new customer objects get set up? And how come the constructor is optional? So the constructor is optional if all of those attributes have been initialized. If you define attributes that are not initialized, then Java will complain and say, no, okay, now you need a constructor to initialize those. If your list of instance variables are all initialized, you're good to go without a constructor if you don't want a constructor. And all the other methods, again, are completely optional depending on what your need is. Note that none of these attributes are private. Like Thursday, we had class B that had the private integer variable val that we could not access. None of these are private, so when we create a customer object next, what you'll see is we can easily access any of these attributes using object.attribute syntax. Nothing's out of scope for us because nothing is private, which is typical of these simple classes. If you make a simple class with something private in it, it's almost useless. So if we do have this super simple class, we could create a new customer object using the syntax customer C equals new customer. So it's the exact same syntax we would use, say, to create a new instance of any object. When we create a new JButton, we say JButton, OK button equals new JButton. When we create a new text field, we say, name text field equals new JText field. It's the exact same instantiation syntax. The first time you use it with a class that you've created, it tends to look kind of weird, or at least it did to me, and you think, wait a minute, that can't work. There's no such thing as customer. That's not built in. Why would I be able to use this exact same syntax? And it's just, this is the syntax Java uses. It knows customer is not a built-in class. It'll look through all of your imports to see if it can find a customer class. And if it can't, then it expects to find a class definition inside of the project. It could be in the same package. Depending on syntax and access modifiers, it could be in a different package. It could be in the same source code file or in a separate source code file. But if you execute a line of code like customer C equals new customer, Java needs to find that customer class for it to work. If it can't find it, it'll be underlined in red and it'll be, a compiler error. Once we have this object C, we can do stuff with it. New customers have no data. Everything's empty. So if we wanted to create a customer, give them a name and an address and so on, we can use, again, the object.attribute syntax. We could say c.name equals Edward Teach, and address 1 is, that's French for X marks the spot. But whatever, we can just use simple assignment to give actual data to this object, and then we can use the object, for instance, to create a report on our pirate customers potentially, which we'll get to. Hopefully we'll get to the screenshot and a brief description today, and then we'll tackle coding it next time. That is a simple customer class. There are advantages of simplicity in that it's easy, right? I mean, simplicity by definition is easier than complexity. And if the simple variation of a class is useful, there's no need to make it more complex for the sake of complexity. We would only add complexity if it made sense to and made our programming life easier. So what is a disadvantage that we can fix by adding a degree of complexity that is actually helpful? Well, the simple customer objects only store data. They have no methods, they have no functionality, they cannot help us do stuff with our customers that might be helpful. All they do is store data. Why is that a problem? Well, let's look at an example. There's a credit card number field that's defined in there, and let's say we're taking this customer's order, or the pirate's setting up their online account, and they put in a credit card number, and they put in -9. And in this simple customer class, that would get stored as their credit card number. That is probably not a valid credit card number. I don't know what credit card pirates, use, but I'm thinking -9 is probably not a valid number. And so in general, we don't want to store what we know to be invalid data in our objects, because then that's going to come out, and in future use of the objects where we try to generate reports and try to do stuff with the data, bad data will generate bad reports. And obviously we want to avoid that. So the simple customer class that we've defined would let us enter bad data. And we can add a little bit of complexity to do some basic data validation so that that's not allowed, or we handle it in some manner. So the normal features that we add to basic classes are what's called getters and setters. And they provide us a way to set data on our customer while also potentially validating it or handling bad data. And then also a way to safely access data about the customer instead of directly accessing a field or an attribute. So for the credit card number, we could do some really basic, simple validation, like make sure it was a positive, integer number. And if they're 16-digit numbers, then we could also make sure that it's a positive 16-digit number. That would do very basic validation. That's not actually how you validate credit card numbers. There's an algorithm invented at IBM called the Lun algorithm, which is fairly convoluted. But that's actually what you would probably do to validate the credit card number, is you double check that it satisfies the conditions of that algorithm. This is just a simple, is it 16 digits long kind of test. But this would reject a wide range of typos that might happen when a pirate's trying to type in their credit card number. Typing with one hand might be a hook. That's tough to do. Errors happen, and we want to be able to catch them and deal with them as quickly as possible. That would be a setter. So we put this basic data validation code into the set methods. The get methods are normally just really, really simple, like one line of code. So for instance, a typical get method for the credit card number would simply return the credit card number. And you might say, well, why do you need that since credit card number isn't private? I have direct access to it. Well, and the answer is it's not really the best idea to make every single piece of data that you use a public instance variable. You normally want to protect some things from direct access and direct manipulation, and you do that by making it private and then providing a getter and a setter, so that instead of directly accessing credit card number, you set it with the set method, and when you need it, you get it. And the get method could be slightly more complex. It could potentially also validate that you have the right to gain access to that variable. It could do more than this, but a very basic getter just returns the value that's stored in that variable. One more cool feature of both of our IDEs is that they will generate getters and setters for us automatically if we know how to ask them to do that. So if you pull down the source menu when you're inside of a class and select generate getters and setters, Eclipse will scan your code, look for the instance variables, and then offer to write just basic default getters and setters for each of them. It comes up with this dialog. You can configure which getters and setters you want to create. You can also tell Eclipse where to put the getters and setters. Do you want them at the the top of your code, at the bottom of your code? It's pretty flexible in terms of what your coding style is. It'll give you an option, hopefully, that supports where you actually would want them. Yeah, that's it. So normally you type in a really simple class, like I typed in this basic customer class and I ran this generate getters and setters in Eclipse. And this is the dialog that you see, which lists out these attributes to generate. And I generated all of them. They're really simple. The getters are typically simple, so the automatically generated getters may not need to be worked on at all. Now the setters are probably a different situation, in that if you're generating setters, it's probably because you want to do some sort of validation. And in the automatically generated getters and setters, Eclipse obviously doesn't know what validation you want to do. So then it would be up to you to take this automatically generated setter and add whatever data validation you wanted to it to make it actually useful, worth having. All right, so a word about constructors. We've been coding constructors, again, since pretty much the first Hello World app. They are methods. However, that violate the basic rules of methods. They don't have a syntax rules. They don't have a return type. They don't say void. They don't say data type. And they're also, the name is capitalized, which violates the style guide. But again, the capitalized method is meant to match the capitalized class, and it's another reminder that this is a constructor method, and it doesn't have to follow the rules or the style guidelines. It gets its own rules. All right, I want to switch over to Eclipse and just do a little bit with this basic pirate customer. And so if you want to, you can follow along, or I'm going to switch to Eclipse, and then we'll start a new project for chapter 10 and create a new class and put it in there and do some stuff with it. Okay, so I'm going to create a new Java project. I'm right-clicking, I'm saying new Java project. I'm going to call it chapter 10. I'm not creating a module, and now I have a new Java project. I want a basic class to do some stuff in, so we'll call it, I don't know, SimpleClassDemo. It is an app, So it is the app that will run and create objects of our class type. So I'll create a simple class inside of this app class. I hope that it's clear in your mind that apps are different. They will have a main method, they will run, and then when they run, we'll create objects of class types that we've defined, such as the simple customer class. In any case, this could be something that has a UI, so it could extend JFrame and do all that kind of setup. I'm not going to do that initially just because it's not necessarily have any, pedagogic value to having this have a UI versus viewing the results of the console. But I still need to construct the app. I forgot to copy that onto my clipboard, so I have to type it, which, once is enough. So there's my main method, there's my constructor method. Now what I want is a simple class, a customer class, say. You could, if you're trying to follow along, you want to follow along and you want to copy stuff, out of the Keynote, that's awesome. If you want to type it, that's awesome as well. I'm just going to type it. It's that I don't go too fast and leave anybody behind. So I'm going to do this simple customer class. So I'm going to say class customer open curly brace. So that's a valid class. It's empty, but we've got the syntax there for defining the customer class that would allow us to create customer objects there. For the simple variation, I'm going to create a few attributes. So I'll say string name, and I'm initializing it initially, and then we'll change it so that we don't do that. I'll say string, so I have to spell it correctly, address, string, city, come on, string, state, int, zip, and we could keep going. There's the, for the pirate customers, there's the loyalty club, our loyalty club, which is, I call jokingly the booty club, because pirates like booty, and because every time I say that, students tend to laugh, and I sometimes giggle as well. Anyway, we could add the point balance here. You could add credit card number. Why don't we do credit card number, just because it's a really common thing that we want to store. Credit card numbers are integers. The point card balance could be integer, it could be double. I did integers last time, Thursday, and I do doubles in the example today, just to give you two different examples. But the credit card number is an integer. Credit card numbers don't have decimal places at this point, but it's not an int integer because it's 16 digits long. And 16 digits exceeds the range of int integers. They can only go up to 2 billion, and 16 digits takes you past 2 billion, or past billions, however you want to say that. So they're longs. Credit card number. And the way you initialize these, has meaning. I've made these blank or 0. But you could also, how Java uses -1 frequently to represent an error of some sort. If you wanted to, you could initialize these to -1 so that if you tried to use them and then you saw -1, you'll know you'd forgotten to do something. Or whatever system makes sense to you, that's what you should use. That is a valid class. It's a simple class. It's even simpler than the simple class in the chapter and in the Keynote. But let's create a customer object. So the syntax is class name, customer, some valid Java identifier. I'll keep with C to mirror the Keynote in the chapter. We use the new instantiation syntax. We list the class name a second time. That will, if a constructor method exists, execute the constructor method. If not, it simply runs through the instance variables and creates an object with those instance variables set to those values. So this has created a customer object. We could test that. We could say system.println credit card number equals plus, and then the syntax to get to the credit card number is object.method. So I'm going to pause here and let you see that all of the attributes that we've defined are listed there. So Eclipse sees this as a valid class. It's looked inside it. It knows what the public attributes are, or the visible attributes, and it lists all of them right here, along with their data type, which is handy. So I want the credit card number. So if I run this, I should see credit card number equals 0, right? Which is what I see. Obviously, it's 0 because we didn't set a value for that credit card number for object C. So if we want to set values for this particular object, we can say, you know, the name is this, the address is, I don't know, 10. I forget the French behind that, but it was just French for X marks the spot. And then I want, you know, city, state, zip, or whatever the case may be. Edward Teach, I mean, if you guys don't know, that's Blackbeard. He was based in Nassau in the Bahamas, which I don't have country, so I'll call Bahamas the state. Whatever. We could keep going with whatever other information made sense, but let's do the credit card number. C dot credit card number. And just for the sake of it, let's say Blackbeard, being a pirate, is trying to put in an invalid credit card number. He's been trying to charge all of his purchases to the Underhill account, but the pizzeria got wise to that, so now he's trying to enter an invalid credit card number to order his pizzas. The thing is, that's going to work. Let's build up a slightly more informative string here. So I'm going to say, well, let's do just a really simple little table. So I'm going to say name /T for tab, and then credit card. And then the next will be c.name plus tab symbol plus credit card. And we'll see how that looks. We may need to add more tabs to the first line because the name might be long enough to require 2 tabs, but let's just run it, see what we get. Yeah, it's certainly readable, but we've got, yeah, it does need a second tab, although it's not critical. But you see now we've got our one pirate customer here, and they've entered their credit card number as -9, which is bad. We don't like that. But what are we going to do about it? I'll show you what we're going to do about it. To handle a bad credit card entry, to stop Blackbeard from entering this bad number and ordering pizzas without paying for them, no matter how bad the pizzas are, we still need the money. So how do we do that? Well, we want to generate getters and setters. We could type those all in by hand, or we could ask Java to make them for us. So inside the customer class, you can right-click and generate getters and setters, or you can pull down the source menu and choose generate getters and setters right here. And this will get us our little dialog box here because I had state selected when I did it, it's made the assumption that I only want state generated, but no, I want all of them, so I'll select all. I have control over where it goes. It's assumed again that I was just generating it for state, so it was going to put it after state. That's not what I want. I would want them either at the top of the code, or for me, I put them at the bottom of the code. So I'm going to say the last member. Sort by the field names, each getter and setter together, which is, to me, is the sensible way to do it. You could obviously have all of your get methods together and then all of your set methods together if you wanted to, if that made more sense to you. I want them to be public. That's the default. That's what I want. I could have it generate basic comments, but they are really basic. But if you're going to comment your code later, which you should, it'll give you the basic syntax for the comment, and then you could just type your comment super easily. I'm going to leave that off. But I hit the generate button and Eclipse wrote all of these methods for me. And you can see it did put them directly after the list of attributes. And they're organized in the same order that the attributes are listed. So it's get name, set name, get address, get city, set city, get state, set state, get zip, set zip, get credit card number, and set credit card number, which is, again, a basic default set of getters and setters. And you might say, why are those needed? Because I can still directly access credit card number. If I can directly access credit card number, then Blackbeard can still enter -9 because he can get around whatever validation I put in here, he can get around it if he doesn't have to use set credit card number. So how do I force that data input to go through my set method? I haven't added the data validation yet. I will momentarily, but just bigger picture, if set credit card number is public, but credit card number is also in scope, then my data validation isn't going to do anything. So I need to privatize credit card number. you'll notice it doesn't go to an error because customer is defined as an inner class. So it's inside of the app class, and public and private only restrict access between classes, not classes that are inside of other classes. So if I want that to work, I actually have to move customer out of the app class and put it as a separate class. Once I do that, you'll see now that Java is bulking at letting us directly edit credit card number. And the error says the field customer.creditcard number is not visible. It's not visible because it's in a separate class and it's private, so you can't see it. So I have to go through set credit card number. So let's change it so that we've got the syntax right. So I'm going to say set credit card number. I'm still going to set it to -9 to start with, and then I can't access it to display it. I have to use the get method, so I'll change this to c.get credit card number. Let's run it just to see that this still works the way I think you would expect, which is it allows -9 in because we haven't done any data validation. So let's add the validation. So we want to add that to this set credit card number method. And the basic one in the chapter is just this check that it's 16 digits. So I want to use an if statement, and I'll say if credit card no for number is greater than, so I want it to be greater than 0 long. And I'm hoping I typed the right number there. Okay. So that checks to see if it's a positive long number. So actually I want it to be greater than 1 and then 15 zeros. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. All right, if I did that right, that should actually give me a check that says this is within the 16-digit range. This is not how you validate actual credit card numbers. You use the Lund algorithm. This is, as a first pass, one if statement kind of test is an easy way to do it. So what you want to do when validating the data is, if the data meets your check, if you believe it is valid, then you go ahead and you accept that as the credit card number. Otherwise, we're going to do something else. We're going to give it an error code. So we'll say the credit card number equals -1. So in our code, we'll write it so that later, if the credit card number is -1, that means it was entered as an error and you need to prompt the user again for their credit card number. So anyway, let's see what happens now when I run this. Well, I mean, let's think for a second. What should happen when we run this? What do you expect to see at the console? So if you're watching the video, maybe pause and think, what do I expect to see at the console? I've set the credit card number to -9. We previously saw -9. Is that what we're going to see, or are we going to see something different? Let's run it. And now it says credit card number equals -1. So I'm hoping that's what you expected. We tried to enter -9. Our data validation says that's not good, so set it to the error code -1. And then we could up here say if c dot get credit card number equals -1. We could prompt the user. We could display a dialog saying that's an invalid credit card number. There are apps in which if I absolutely need an answer to that's valid, then I'll create a while loop and essentially say something along the lines of, while the credit card number is equal to -1, continue prompting the user for a valid credit card number. If credit card number was not essential for submitting this form or recording this customer's information, then obviously that would be overkill. But you could certainly do something fairly easily here that says, that's a bad credit card number, or again, display a dialog that says that, or whatever you might want to do. All right, that is the simple customer class. That is generation of getters and setters, and that is a basic data validation example. All right, I'm going to switch back. And I just want to show this to you and briefly describe it again. But this is where we're stopping. This was my goal, was to get here. today. So the pirate customer report, this is essentially a second take at the membership level analysis that we did Thursday. But there were problems with the way it was coded. The data was stored in two arrays that were completely unrelated, but they had to be related. We had to assume that they were synchronized, so that if you remember on Thursday that there was an array of strings for the pirate's name, and then there was an array of integers for their point club balance, or it was called doubloons on Thursday. And we had to expect that in whatever way the names were sorted, the integer values for their point club balance were also sorted the same way. In other words, were synced. And it's not something we could really guarantee. We could certainly make a mistake coding that would get those two arrays out of sync. So it was not a great way to do that. So what we're going to do next time is we're going to create a pirate customer class, and it's going to include this loyalty club, booty point balance, either as an integer, as a double, or however we want to code it. But it's going to encapsulate that together. So the name and the point club balance will be linked, and we'll only need one array then. We'll create one array of pirate customers. We won't have to worry about, is Captain Kidd's balance, linked correctly? Is 2.59 or 95 actually Captain Kidd's point club balance? Or did I screw something up and have the two arrays out of sync? There aren't two arrays in this. There's just one array. It's an array of pirate customer objects. That's what we'll code next time. And it'll take a big step forward in terms of, I think, when you see the code, in terms of readability, maintainability, and our assurance that the data is valid. That's all I've got for today. This is where I wanted to get to. We'll pick it up next time on this slide, Pirate Customer Report.